What if, for the last century, we've been looking at the entire universe through a kind of conceptual tunnel? Well, today we're going to dive into a fascinating and pretty radical argument that claims modern physics took a wrong turn, and it all started with a simple oversight. This is a totally different perspective, one that really challenges the very foundations of how we think about space and time.
So, the whole idea we're exploring today hangs on this one really provocative question. What if special relativity, a cornerstone of modern physics, missed something absolutely essential, right from the very beginning?
So what was this so-called oversight? Well, according to our source, it's a concept they call shintai sanzai, which translates to physical bodily existence. The author actually points way back to the philosopher René Descartes, and they refer to him as Descartes Senpai, which is a sign of respect, kind of like calling him a pioneering elder. The argument is that Descartes was the first to really get that the observer's physical body is located at a specific, measurable spot on Earth. All right, here's our game plan for breaking this all down. We're going to start with Einstein's supposed blind spot, then we'll look at a classic physics problem in a new light, rebuild a coordinate system around an actual observer, see how that totally flips our idea of time, and finally, we'll talk about what it means to step out of the tunnel.
Okay, let's get right into the heart of the critique. The source is basically claiming that all the weird effects of special relativity, space contracting, time slowing down, aren't actually real physical events. Instead, they're what the source calls an image trick.
So, what in the world is an image trick? Well, the author defines it as a kind of illusion of the mind. The argument goes like this. When physics relies only on abstract math and gets disconnected from the physical act of looking at something, it just ends up creating paradoxes. It's a trick our brain plays on us, not something that's actually happening in reality.
And to really drive this point home, the source takes a fresh look at one of the most famous thought experiments in the history of physics, the good old train paradox.
So on the left, you've got the standard textbook version for someone sitting on the train. A flash of light from the center seems to hit both ends at the exact same time. But our source steps in and says, hang on a second, that ignores a really simple physical fact. The train is moving. Because the back wall is literally moving toward the spot where the light flash happened, it has to get hit first. No paradox, no weirdness, just simple motion.
And this right here, this is the core of their whole argument. The author basically says that the one thing that separates real physics from pure math is the shintai, a physical body making a measurement from a real location. The moment you take that body out of the equation, you start getting paradoxes.
Okay, so if the old way of thinking has a flaw, what's the alternative? Well, the source suggests we should just rebuild our whole coordinate system from scratch. But this time, we're not going to start with some abstract point in space. We're going to start with the observer's own body.
All right, let's actually build this new framework together. First, we put our observer right at the center of the sun. Easy enough. Next, we have to orient them, so their vertical z-axis gets aligned perfectly with Polaris, the North Star. And finally, we just plot the Earth's orbit on that flat, horizontal XY plane.
And here's where it gets really, really specific. The observer's navel becomes the absolute origin point, 0, 0, 0. Their head points up toward positive z, and their feet point down toward negative z. Now this body is totally anchored in the cosmos. You've got Polaris way up at z equals plus 1,000, and the Southern Cross way down below. See, this isn't just some abstract grid. It's a coordinate system built around an embodied, oriented point of view.
And now, the payoff. We've built this new system, so what? What does this embodied perspective actually show us? Well, according to the source, it completely changes how we understand time and observation itself.
Let's do a quick geometric puzzle. Imagine for a second that you are the observer, but you've zipped all the way up to Polaris. From that amazing vantage point, you look down and you see two things: the sun sitting there at the origin and the Earth orbiting around it.
First question, what's the distance from your eye at Polaris straight down to the sun? Well, in our simplified little model here, we'll just call it a nice clean 1,000 units.
Simple enough. But what about the distance to Earth? Well, since Earth is orbiting on that flat plane, it actually forms a perfect right-angled triangle. And you know what that means. It's time for some good old Pythagorean theorem to find the distance. And the result you get is about 1,000.05 units. Now, I know that looks like a super tiny difference, but trust me, it is everything to this argument, because it means the Earth is always just a little bit farther away from you than the sun is.
And here it is, the absolute kicker. If light travels at a finite speed,
and the distances to two objects are different, then the light from the sun and the Earth cannot reach your eye at the same time. The image of the sun you're seeing is from 1,000 units of time ago, but the image of the Earth is from 1,000.05 units of time ago. Your view of what you think is now is actually a mosaic, a patchwork quilt stitched together from different moments in the past.
This brings us to the grand conclusion of the argument, which the source beautifully calls the exit from the tunnel. It's all about waking up to a totally new kind of spatial awareness. The source claims that physics without this embodied observer suffers from something called Shikoshiya Kyosaku, which basically translates to a narrowing of the field of thought. It's like having intellectual tunnel vision, right? Caused by relying on abstract math and forgetting the physical reality of just looking at things. And this contrast just frames the whole argument perfectly. On one side, you've got the tunnel. That's physics built on abstract ideas where the observer is totally missing from the picture. And on the other, you have the exit, a physics that starts with the observer's body, where simple, straightforward geometric distance is what dictates time.
So, after all that, what are the big takeaways from this pretty unique perspective? Well, first, that any real description of the universe has to start with the observer's physical location and orientation. Second, that our perception of a single unified now is just an illusion. We're only ever looking at a patchwork of the past. Third, that geometric distance and time delay are two sides of the same coin. You can't separate them. And finally, from this point of view, the famous paradoxes of relativity aren't really problems we need to solve. They're just illusions that completely dissolve the moment you put the observer back into the equation.
And all of this leaves us with one last, truly mind-bending question to chew on. If everything you see right now, this screen, the room you're in, the most distant stars in the sky, is just an image from a slightly different past, then where, or maybe when, is the true present moment?